when you're looking at the given function itself, your stretching factor is the absolute value of a. So here, the negative, you can disregard that as far as the stretching factor goes. That would simply take your graph, and instead of it being a decreasing function, it would be increasing. But the absolute value of that would be our stretch factor. The period we just saw, take pi divided by whatever the multiplier in front of x would be. So 4 pi over 7, dividing by 4 pi over 7 is like multiplying by the reciprocal, 7 over 4 pi. Pi's cancel, and so we would get our period to be 7/4. Okay. And then the vertical asymptotes, if there's no shifting here, the first vertical asymptote is the origin. And then you could use the period to find the next one. Again, tangent and cotangent functions, their asymptotes are one period away from each other. So if this is the vertical asymptote that's nearest the origin, and the instructions should say at or left of the origin, okay, 0. And then the one to the right of the origin is going to be 0 plus the period, which is 7/4, which would mean if they wanted another one, you could go to the left and get minus 7/4. But again, I believe the instructions that you'll see will be at or to the left of the origin. So choose the one that's at first, if it is. So when you're looking at this, the stretching factor is the absolute value of whatever multiplier in front of the trig function, so 3. The period can be calculated by taking pi divided by whatever the multiplier in front of x is, the b value inside, which is pi over 8. And then when you're dealing with vertical asymptotes for the cotangent function, it starts at 0, and then you take into consideration the shift. There is no shifting here, so we can start with x equals 0, and then use the period to go 1 to the right, 0 plus pi over 8, and that gives you your vertical asymptote.